Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar, we'll be doing a drawing for 6 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 6 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is Business Continuity with Microservices-Based Apps and DevOps, Learnings from 8x8's Experience. Our speakers today are Pankaj Gupta, who is a Senior Director at Citrix, Lance Johnson, who is Director of Engineering Cloud R&D at 8x8, and Mike Lewis, who is Senior Site Reliability Engineer at 8x8. Welcome, gentlemen. Thank you so much for joining me today.
Thank you.
Pankaj, I know that you are going to be the primary speaker, so I'm going to put myself on mute and let you dive right on into your presentation.
Thank you. Welcome to the DevOps.com webinar. I'm Pankaj Gupta, and you can also find me on Twitter, Pankaj on Cloud. I have a distinguished panel of Lance and Michael from 8x8, and they are really shaping 8x8 journey to microservices-based applications, and they will be sharing their amazing experience and insights from their experiences of implementing microservices-based apps. And microservices-based apps, also fondly called container-based or Kubernetes-based apps, are very critical for any business continuity. As you know, microservices-based apps bring many benefits for business continuity. 3 benefits stand out very clearly. Number 1 is the modular architecture. Number 2 is the faster releases. And third is the portability. In microservices-based application, you take an application and break into a very small microservices or set of microservices. The benefit of that each and every microservice can be developed, deployed, and auto-scale independently. And that gives you agility to respond to the changes for your business continuity and also roll out new features functionality more often, sometimes many times a day. And that actually helps you to do a implementation of continuous integration and continuous delivery. And in the times of business continuity, ability to develop, deploy, auto-scale each microservice independently, and also continuously deploy is a huge benefit. In business continuity environment, you also want various choices. You should be able to take your application and port it or implement or run it from any public cloud or any other environment. And that's another big benefit which microservices-based application bring it. To summarize, 3 biggest benefits for microservices-based application in business continuity is modular application architecture, faster releases, and portability. And if you want to read more about it, what is the relevance about microservices-based application for business continuity, please read an article at the tiny URL mentioned here, which will give you more insights. And in a business continuity environment, there are multiple stakeholders which you have to take care with your application architecture, with your implementation to achieve the goals for business continuity. The most important one here is the DevOps. They are continuously looking for faster and quick release cycles, looking for more automation, And that's what Lance is going to talk about. SREs, which Mike is going to talk about, they look for application availability, observability, incident management, and of course, NetOps is looking at how do I implement network policy and remain compliant even the times of change or even in the times of business continuity. So it's not an easy task to take care of so many diverse stakeholders. So when you're planning for business continuity, you have to consider multiple stakeholders that how you take care, and that's what 8x8 experience will also share some of the insights and best practices to achieve individual uh, stakeholders' goals. Citrix offers solutions for microservices-based application delivery. We offer proxies, load balancers, or application delivery controllers, whatever you like to call it. Our solution is built on 5 fundamental principles, and they are typically in a step as you make the decision for the right application delivery infrastructure for your business continuity. First is the architecture flexibility. There are multiple architecture choices, and your IT should be able to move at the speed your business wants to be. And you would like to balance benefits versus complexity, starting from as simple as two-tier ingress to the nirvana of service mesh. We will see a little bit later what are the different 4 architectures. The second principle for application delivery infrastructure that whatever solution you choose, it has to integrate with your platform and tools, because you will like to get your application to the production fast. And Citrix integrates with variety of Kubernetes platforms and supports a very large number of open source tools. Third one is performance and scale, ability to support large cluster, having a better performance and lower latency is the third criteria you have to look at when you choose the right microservices based application delivery. And security should not be afterthought. A consistent security posture and API security across the monolith and microservices should be considered so you are always compliant. And if you can't see, you can't fix it. And that's the reason you really look forward for a complete observability stack so you can actually gain visibility and troubleshoot problems faster. An observability stack is built upon 3 golden signals of logs, matrices, and also service graphs into that. And the last is you really need a production grade solution in the business continuity environment. Lee Kolkate and myself did a very detailed white paper which talks about the 7 key considerations for microservices-based application. If you like to read, you will find the URL mentioned in the subtitle here. Just a quick preview of what Citrix ADC solution is, Application Delivery Controller. Citrix offers a very comprehensive, very feature-rich, software-centric application delivery controller portfolio, starting from virtual appliances, which are available for your on-prem as well as in the all major public clouds, and also available in container form factor as well as a sidecar for your service mesh environment. If you're looking for bare metal or hardware appliances, which we offer too. But the benefit of Citrix ADC portfolio is the single code base. So you have the feature API and operational consistency across the whole portfolio. So if you want to move your workloads across the environment or across the form factors, you can do that very easily. And that comes very handy for business continuity requirements. These are the 4 architectures to consider. They are plotted in 2 axes. On the bottom, you see the complexity, and on the vertical axis, you see the benefits. Two-tier ingress architectures are simplest and quickest to the deploy, gives the network teams control of ingress and gives the clear demarcation and control for all application delivery controller or load balancing inside the cluster. The North Star for many teams has been the service mesh, which gives you the best observability, best security, and also gives you a very granular traffic engineering control, but it's very complex. But if you want a service mesh light functionality, Citrix also offer a variant of service mesh, which we call it service mesh light, which gives you all the key features of observability, security, and granular traffic control of service mesh, but makes it very, very simple. So if you are considering what should be your right architecture, I strongly recommend of a series of articles which we have published, which goes into each and every article, architecture and discusses pros and cons. And the URL is tinyurl.com/proxy architecture. Without further delay, I would like to welcome our 8x8 team and request them to share their journey to microservices-based applications and some of the great learnings with other DevOps teams can learn from. Lance and Mike.
All right. Well, thank you, Pankaj. Appreciate it. And thank you, everyone, for taking time out of your day to attend. And to the DevOps.com team for organizing, much appreciated. So my name is Lance Johnson. I work at a company called 8x8. I'm here with Mike Laws as well. So both he and I have been working hard to help engineering teams and operations kind of keep everything working and keep things moving. So we're here to talk about what I like to call the DevOps three-body problem. So like I said, my name's Lance. I'm here with Mike. These are some of the, my attempts at social media, I guess is the way to put it. You can reach me on those different areas.
As you can see, I'm not very social.
Yeah, I could see. I got a computer science background, and half my career's been in the engineering side, and half my career's been kind of on the operations side. But some of my most favorite badges are on my laptop, and ironically, I've been stuck on the same CPU and the same memory for 5 years because I cherish the picture, the stickers on my laptop. It's hilarious. I go to conferences and my wife says, "Conference? No, you're going to a sticker trading fair." So it's so 8x8. We both work at 8x8. It's a unified communications platform. We have 1,600 employees across 8 different countries. You got a ton of business users all over the place, every country you could think of. And we provide a seamless integration or seamless experience across meetings apps, chat, voice, and even call center. So it's one-stop shopping, and you can communicate with pretty much your entire team, any customers you have, and meetings. So the three-body problem. So I like this analogy. It's the basics of it, though. It's an unsolvable mathematical problem. It's I think the problem that almost drove Newton insane when he was figuring out how the heavenly bodies moved and gravity and whatnot. So even though he invented calculus just to describe what he was thinking, this is a problem he couldn't solve. So essentially, multiple bodies pulling on each other. There's no closed mathematical solution that will predict their paths and stuff. So what does that mean? So what is the DevOps three-body problem? So you've got how do you get your stuff where it should be? How do you get it deployed? There's the rudimentary, there's the exotic, there's the automated, Ansible, Chef, Terraform, CloudFormation. So that's one thing that's always pulling on you. The next problem in that triangle is kind of how do you get your customers to the right service in the right place? You've got, DNS, and you've got proxies, you've got, geo-aware DNS, but how do you know that they're actually talking to the right place? And lastly, you've got, we're all on the same journey of like taking monoliths or like refreshing stuff, and you've got dependencies that are pre-existing. You got files and databases and random VPCs all over the place, public and private. And so all three of these kind of pull with different gravities at different time, depending on who's screaming the loudest. So, how did we approach this problem? We're a 25-year-old company. It's not exotic. We took the same journey that most people are taking. We decided to go with containers for a packaging system, and Kubernetes is the du jour of deployment and management of those workflows. But how did we do it? Gangnam style. We've done a lot of stuff, and we've had a lot of good experiences over the past couple of years. I think we started at 1.8 in Kubernetes, but we've had a lot of successes. But even though sometimes I felt like we were pretending to ride a horse as opposed to actually riding one. But that being said, it's funny, I put this slide in every single presentation. It drives my boss crazy. Like, no matter what the context is, I always drive this home. These are the fundamentals that we want everyone across all of our teams to use whenever they are implementing anything. We want everything to be safe, provide a way to validate that it worked. Everything needs to be done in an automated fashion. We want it done exactly the same way in every single environment to remove the ambiguity. We want to do it openly and collaboratively. And we want to, enable teams. We want to give them the autonomy that you get them up and going, and they don't have to come back to you, and they'll love you, right? Because they get their stuff done faster and faster. So it's the traditional DevOps mantra, I would say. So with microservices, how did we approach it? Why? It's the traditional story. You want to that Pankaj kind of alluded to in the beginning. You want to break it into smaller chunks, make it easier, divide and conquer. You want to slowly start to refresh and use newer technologies, not because it's much harder to. I don't know anyone who's just had a complete working production platform and just decided, let's go from scratch. So it's kind of a gradual. And you want to give those teams autonomy to go as quickly as possible. So some of the services we chose first, we did the way we were deploying it in Kubernetes was brand new to us. So we did start first with, what a framework, a foundational framework to build upon. And then, the first set of services after that were what we call kind of shared services. We wanted to do stuff for the engineering teams wanted to do stuff for teams that weren't directly associated with the feature or the value that they were doing. Like, I don't know, like RBAC, like it's a vanilla, mapping people to groups and stuff that doesn't, so stuff like that. And then the other thing we tried to do to make our lives easier as we kind of learned Kubernetes is stateless applications went first. So it's much easier. It fits more naturally with transit containers and pods and whatnot. So our design goals, it's nothing exotic. It's just a pretty traditional Kubernetes cluster. We started cloud first. We wanted to put it in a place that an environment that kind of didn't have an identity, so it was easier for everything to be uniform. We wanted service discovery so that you don't have to like send an email to figure out the DNS, blah blah blah. We wanted it to be high availability. So this is the traditional Kubernetes story, right? We were coalesced around container packaging. Obviously, we wanted to be able to use as many off-the-shelf charts as possible, but we also, part of that framework, we provided a scaffolding that would, most teams, their chart that encompasses their service is just one line. They have a requires to a common chart, and then they call one template, and then we take care of everything else. And kind of another view to that, if you don't like the 3D. So, we spread the cluster across multiple AZs. We not stateless, so we don't have to worry about the store. We're we're stateless, so we don't have to worry about the storage, or at least initially we were. And we, went East Coast, West Coast, and set up a replication for the databases. We stay away from super high volume. This isn't for something that's an amazing throughput of databases. So it's for the replication, it's the cap theorem. You can only go so far when you're that far apart. And then we put, cloud load balancers in front of it, mainly because some services we needed to bring our own APs, and some services we knew we would be first in the cloud and then on-prem, and so we coalesced around Cloudflare. Was the most flexible at that time, and so our environment started out. We brought in one cluster as we learned how to do Kubernetes and learned how to manage it and can control it. And then, we quickly said, okay, we need more than one. Obviously, just one environment has become many different clusters at this point, and so we put a cloud load balancer in front of it. That became our environment, but it quickly started to grow. And we wanted to be able to insulate the access to the cluster even through the load balancer, so that as we swapped in new clusters, a full upgrade could be put a cluster right next to it with the new version, and then move over to a managed service like EKS. And then it also works when we start bringing the on-prem stuff, and we'll get to a slide, and Mike can kind of describe that infrastructure, and that's where Citrix came in and is giving us the same flexibility to use the native Kubernetes and its cloud providers. It's fully featured in the Citrix one as well, so it's been great. But this allows us to also, EKS is the first one we're going to. We were deployed in 1.8, I think, before EKS came out, but now there's a plethora of Kubernetes managed services, even on Oracle. So OKE is one of the other ones we're going to try, and then and then the on-prem. So that's kind of what our hybrid environment looks like. And so for our on-prem stuff, I'll let Mike kind of talk to this.
All right, thanks, Lance. Thanks, everybody. Hope everybody's out there staying safe and doing well. Yeah, kind of continuing with what Lance was saying, we do have this hybrid environment that we're now operating in, and the newest piece of that is our data center presence for Kubernetes. And this really kind of illustrates what that looks like. And it's taken a lot of time for us to kind of get to this point. We've gone through several iterations and sort of all of that learning that we did in AWS without really having to be too concerned about the infrastructure, load balancers, storage, all that sort of stuff that you sort of get for free, more or less with AWS. But once you bring that into the data center, you've got to think about all those things now. And so it's taken 8x8 a little while to kind of get those pieces in place and really start to get all of those best practices and all that design work implemented into the data center. And so what we did was what you see here. We went with mainline Kubernetes. So this isn't something like OpenShift or anything like that. This is mainline 117.6 today. So we're pretty cutting edge. We're not at 118 yet, but we're past 116, which is kind of that hump where some API changes were made, which we learned the hard way. But we're also doing, as part of this, Kubernetes came in as part of this larger, what we're calling our next generation infrastructure project. So that's really kind of a top to bottom redesign of what we're doing in the data center. And part of that was really implementing the notion of clear defined zones. Again, something that we really learned and picked up from AWS for a variety of reasons. I guess not least of which is just the notion of being able to, with a sort of an abstract concept of a availability zone, to be able to say, if I deploy a workload in that zone, I know it's physically separate from a workload in zone B or zone C. So that was an important part of what we're doing to kind of prepare us to get to that production grade Kubernetes infrastructure based on a layer 3 leaf spine infrastructure. I won't go too far into that today, but that was another kind of big part of what we did. And the storage, like I mentioned, was a big piece of kind of that, you know, how do we get Kubernetes to a point where we feel like it's a production ready service? And part of that is being able to take that second look at storage and say, you know, how do we ensure that storage in zone A and zone B and zone C doesn't introduce any sort of cross failure domain dependencies, right? So if we have a workload in zone A, storage in zone C goes down, we don't want these unintended effects in zone A. So, you know, it sounds like a simple concept. When you get to the data center, that's where things, you know, it gets a little more interesting because you've got to actually, again, you've got to think about that stuff and how that's architected. So it gets a little hairy, but that's a piece of the story here. And then for networking, and you know, this is a Kubernetes discussion primarily. So you know, we're using BGP as sort of our control plane on the networking side, and Kubernetes supports the Calico CNI, which for us was sort of the answer to a lot of problems, scale issues, routing issues across zones, and also speaking to Citrix specifically, it was also a way for us to really plug in Citrix in a way where we were ensured that this was going to scale to whatever workload whatever capacity we needed, and scale in a real simple and easy way. And then we also went with BGP for a lot of other kind of outside of Kubernetes use cases, such as I mentioned here, BGP down to the host, which gives us some pretty interesting capabilities as well, you know, Anycast and things like that. But as you can see from the diagram here, each one of our zones is basically what you would almost consider to be the Kubernetes stack. You know, you've got your storage layer at the very bottom. Each one of your Kubernetes nodes is using that storage within the zone for persistent volume claims, things like that. And then, of course, what I'm calling the Kubernetes control plane, the C plane layer, the purple box, which is, for us, that's a combination of etcd, the Kubernetes API, things like that, and the workers that really kind of handle the workload pods are the green boxes, the K8s nodes. Above that, you have essentially our load balancing layer, the Citrix ADC, which is a huge part of this this implementation. Again, those are working with Kubernetes. So when you deploy something like a service of type load balancer, or you deploy your Kubernetes ingress, that's all being handled through what they call the Citrix, Citrix ingress controller. Picks up those events, makes the appropriate changes programmatically to the load balancing layer, and then that those VIPs or whatever the services are presented up through the network, in our case via BGP, out to the wide open internet, and that's how we make services available to the internet. And for us, that stack really provides the ability, kind of what Lance was saying a minute ago. One of those things that we're really trying to achieve here is how do we kind of increase the velocity for a lot of our development teams, application teams, and allow them to deploy these services in a iterative manner, or in a very how do we achieve that goal of quick turnaround, fast deployments, things like that. And a part of that answer was really designing this Kubernetes stack in a way where we have very few kind of manual handoffs and interactions happening. Literally, we say we need to deploy a service within Kubernetes. That service may or may not require persistent volumes. You literally deploy your service, and the storage is provisioned for you through Kubernetes. Kubernetes also handles the public-facing side of that through the Citrix ADC, and provides that service out to the whoever our users are. And that could also be what they call east-west services as well, right? So services that are really intended for kind of within the infrastructure between your microservices, so that the ADC can handle both of those cases. And I guess going back to Pankaj's slides at the beginning, he had sort of those 4 different architectures that he talked about. And I guess we would technically call this sort of the unified ingress. And for us, that was really a move to kind of simplify the network, simplify the infrastructure, which for 8x8 was a big deal. How do we take what is currently a very complex service delivery, application delivery tier in our infrastructure, and really simplify that, make it high performance, horizontally scalable, and programmatic, in the way that Kubernetes can perform a lot of those configuration changes for us. So anyway, sorry. Next slide. I didn't want to go too far into that.
That's it. We didn't come up with a safe word for queuing me up to go to the next slide.
Right. But I wanted to go real quick, and I'm sure some of us are more interested than others in this piece of it. But when we talk Kubernetes, it's kind of fun to get into the what's under the hood here. So the anatomy of each one of these zones, I sort of talked to that a little bit, and some of us, we like to talk speeds and feeds and stuff like that. So that's really what this is about here, this slide. We implemented something called a route reflector in each zone. So that's sort of our BGP interface. And so what that means is, every organization is going to have your NetOps team, like Pankaj's slide, your stakeholders, kind of is part of the larger population of users here of the system. And so every time there's a handoff, let's say, we've got NetOps, you may have your storage team, you may have your team that handles your load balancers, your ADCs, SysOps, all those various teams. When you look at something like Kubernetes, that sort of spans all of these disciplines. And what we wanted to do was really provide some infrastructure that allows us to kind of respect those boundaries between the teams. Hey, the NetOps team may have a way that they're doing business. Our storage side may have a way they're doing business, but we still need Kubernetes to kind of span all of those and be able to freely provision those resources across those disciplines. And so for us, the route reflector was a really convenient way. It's a convenient way for us to interface with the network without necessarily going to, as you can see at the top, the leaf or the spine layer, and integrating at that point. And route reflectors are something that could be implemented safely in VMs or even containers, for that matter. And for us, like I said, it was a convenient place to integrate. Calico also speaks with the route reflectors, and that's how you get that unified pod network across the infrastructure, across zones. And then, of course, the Citrix ADC, which was, for us, that was a huge requirement. We knew architecturally that we wanted to leverage BGP. We wanted to advertise VIPs via BGP. And we wanted that to be able to span zones as well, so that we could take advantage of other technologies, like I mentioned here on the left, ECMP, equal cost multipath routing, right? So that if we have multiple instances of the Citrix ADC, and we scale that up, let's say we start off with 3 of these, and we find out that we need more SSL throughput in our application, we can easily scale that up and leverage technologies like ECMP to spread that load across multiple instances of the Citrix ADC as our capacity needs change. So we don't have a complicated layer there. Again, it's a very kind of well-defined, well-contained unit of functionality that we can then horizontally scale. So that was a huge kind of design goal for us in this infrastructure. And again, one of the real kind of key wins for us going with Citrix was It supported our zone isolation goals. So we had the ability to say, here, we're gonna have Citrix ADCs running in zone A and zone B and zone C. And if we deploy a service that, let's say, is only operating in 2 of those 3 zones, only those zones should be advertising the VIP for those services, right? And that allows us to really kind of target those services to those specific zones, and it provides that zone isolation. If zone B happens to fall over, zone A is still alive. We're still moving traffic to zone A. Those ADCs are still advertising the VIPs, and of course, Kubernetes is going to do its job and bring up those resources in zone C or whatever the surviving zone is. So for us, this all sort of came together with this kind of single zone architecture, and it allowed us to kind of then take that and cookie cutter that across 3 zones, which is what we're operating today in our data centers. And so far so good. It's been a kind of interesting journey getting there, but today we have what I'd consider to be a robust architecture behind our Kubernetes infrastructure. And with that, I guess I'll move to the next slide here.
Yeah, and Mike, with all these capabilities as well, the teams are still like 99% native Kubernetes, right? That was one of the things that helped with the Citrix. It supports annotations, so they barely have to change going from an Amazon to an on-prem. We just change a small set of annotations, right? And you get all this stuff. They don't need to know any of the route reflector BGP stuff. They just kind of get that for free.
Exactly, and I think that's the part. Obviously, I'm really interested in the speeds and feeds and the infra side, but absolutely, that was one of the kind of key requirements that we had of, and for 8x8, we looked at several different solutions for our load balancing layer. I won't name all the names, but you name any of the big guys, we've talked to them, and Citrix was really the one that kind of met all of our needs for that layer. Again, BGP, very important. The scale side of it, very important. And the other thing that was very important is that when we kind of went down the path of this design and architecture and kind of mapping this out on paper, they were one of the few providers that didn't say no, right? And they didn't try to talk us out of it, right?
Nice.
So it was we had a great partnership with Citrix. We've been working with Citrix for years and years and years in other parts of our business, and so it was a natural fit for us from that perspective. But to your point, Lance, that was another key piece of it, was despite all of that kind of integration and technology and moving parts kind of behind the scenes, at the end of the day, that interface, that Kubernetes native API was first and foremost on the list. We wanted to make sure that moving from provider A to provider B to provider C didn't require us to go down the path of some proprietary or not non-standard interface to provision those resources. So it was very important piece of that. All right, and I feel like I kind of talked through a lot of this here, but this was a lot of the reasoning for us to kind of go the Citrix ADC route. And I know I'm kind of hammering on the Citrix, not just because they're they're kind of a sponsor of this for us, but also because it was just such a great partnership for 8x8. They supported, like I said, the native Kubernetes services and ingresses. And if you guys are familiar with ingress classes, those are really cool, and it was sort of an added bonus with the Citrix ADC. I mentioned briefly a minute ago about east-west services, north-south services. So for those of you that don't know, north-south service are typically services that are providing services external to your network. These are typically when someone's accessing your services from the internet, for example. That's what we consider a north-south service, and an east-west service would be sort of that microservice to microservice communication. And when you've got something like an ingress class, what you can do is say, I have a tier of load balancers that I want to call my east-west load balancers, and you can actually annotate an ingress class on your service and say, I want this to be an east-west ingress. And the Citrix ingress controller will actually take that and say, okay, I'm going to target these specific ADCs that may be in a different zone in your network, maybe a different location behind the firewall, what have you. And then if it's a public north-south service, that could be a different ingress class, and that's native Kubernetes, and Citrix handles that really well on their side.
Nice.
Their support for, like I mentioned, complex zone-aware infrastructure for us, BGP support, no-brainer, and the horizontal side of it, you know, again, it kind of plays into the BGP and everything, but the linear scale of that was a real important piece. We didn't want to have this vertical scaled kind of heavyweight thing sitting in front of our applications. We wanted something where we said, if we need to scale this, we can do that by adding more capacity horizontally. That was an important piece. Rich feature support. So I won't get too far into that, but the Citrix Ingress Controller has a lot of features beyond what we're talking about here today, for things like IPAM, policy management, rule sets, certificate management even. So those are all amazing features that we're taking advantage of on the 8x8 side. And for us, it was just a simple configuration, flexible licensing, all the things you really want from a partner providing this sort of service. So it's been a great kind of a great decision for us, and like I said, it really plays in well with kind of the architecture that we set forth, which really put a lot of power into 8x8's hands, right? We said, hey, look, we know where we want to go with kind of our next generation infrastructure, and we need to find that partner that's going to be able to make that happen without a lot of pushback, and we were able to get that done very quickly with Citrix. So I'll end it there.
Yeah, so you know, like I said, we started back in 1.8 and are now up to 1.17 and have clusters on-prem and in different clouds. So if I was able to, you know, go back in time, use the enterprise or something like that, loop around the sun and talk to myself 2 years ago, these are some of the things I would emphatically say, dear God, pay attention to this while you're doing it, while you're learning it. But so number one, you know, choose your battles. We started with just stateless microservices, just to make it simple as we learned Kubernetes. We were lucky enough to also be able to, the engineering team generated a framework from the ground up for the microservices. And along those lines, you know, the second recommendation, alignment, we were really close with the leading development team that was setting the standards for how our microservices were going to be deployed, and they had a lot of pull to make it happen. So you know, your best friend should be that team. We also, you know, took the approach of self-service. We wanted to get them up and running so that they could do things without having to open a ticket or send an email or whatnot, you know. And you know, it's the traditional Kubernetes story. You know, we got them up there. It's a state system that maintains the state, and then we could make updates to Kubernetes and they could make updates to their services. We didn't have to deal with each other. We went cloud first just to get off the ground, just so that there was no personality to the environment we were dealing with, and plus everything was 100% automatable from day one, right? And this last one, number 5, or this number 5, actually, Mike and I probably laughed about this. This one actually, out of the gate, Kubernetes will not put guardrails to make your system safe. I don't know how to say it.
This was an important one.
Yeah, this one was huge, because we were like, hey, sweet, it's working, everything's up and running, you know. But every single pod was getting carte blanche on the nodes, and it was very easy for one particular service to just destroy a cluster, almost. So there's when you start up the kubelets, there's ways to reserve the resources just for the system, and then for deployments per namespace, there's limit resources, so that you know, the CPUs and the memory each pod has access to, you can restrain it by default and stuff like that. So if you don't do anything and it puts zeros down for that to Kubernetes and to Docker when it actually instantiates it, that means it has 100% of it. One container can have 100% of it. So that was a huge one that.
And I want to add that for on-prem specifically, that's very important, because you don't have the luxury you do in the cloud of kind of saying, well, just spin up another node, right? I ran out of resources, give me another node. You may not have that luxury on-prem, so being able to manage those resources is super important.
Let's see, trying to get to the next slide. It's okay. Embrace a service mesh is the next one. We punted on that because we were learning Kubernetes, and everyone's first response was, well, that's just another layer of complexity. But we regret it because trying to retrofit that after the fact of getting stuff off the ground is a lot harder. And you get a lot of stuff with it. You get better security, you get telemetry out of it, whatnot. From a security perspective, everybody wants kubectl, but that's essentially God mode. You want to be really careful with that. Helm charts are great. It's kind of like Yum packaging for your microservices. We eventually created like cluster role definitions for like power users and for like read-only, so development teams can see everything they need to see, but more of the DevOps or SRE roles could get in there and kill pods and help the system along if they needed to. Make your decision on the ingress versus services early on. Just start with ingresses. It's much better. It saves money. You don't have every single service trying to instantiate load balancers, which cost money in the cloud, and you can have more control over it. And if you don't kind of embrace that early on, then if a developer doesn't have access to something, the first thing they do is they'll write it, right? So because we kind of punted on that a little bit, we're now trying to retrofit that framework for a more generic ingress strategy. And then just the normal get your logs off, get it out there so that you can. That's even regardless of Kubernetes, but it's even more critical when your pod could only be there for a few minutes and then it's gone. There's no chance to debug it unless you have your logs off into a log aggregation system. And same with the metrics. So we use daemon sets for that. So we have FileBeat for across all the nodes. It has access to all the logs from all the containers and then the metrics. And Prometheus is great. It's free. It's a vast library of existing dashboards already. You don't even have to do anything. That being said, we did have access to New Relic and sending it to PagerDuty, and that's been really nice as well. It's just super expensive. So there's all kinds of solutions out there, and even from Prometheus and the Alert Manager, you can send stuff to PagerDuty or directly to whatever system you're using for alerting and whatnot. But those are some of the lessons we learned when we tried to solve the unsolvable problem of the three-body problem. And with that, I'll hand it back.
Thank you, Mike. Thank you, Les, for amazing insights. So we have a few questions.
Yeah, we do have about 7 or 8 minutes left that we can go through audience questions. Obviously, there is time. So if you do have a question, please go ahead and use your GoToWebinar control panel. And why don't we go ahead and dive right on into the questions we do have. Okay, first question. In the deployment environment on-premise slide, are the Kubernetes clusters running in sync? If a request comes to zone A and zone A goes down in the meantime, can it be served by zone B or zone C?
I'll answer that. So with the we have a load balancer in front of the Kubernetes API. So if we were to send a request, it's going to get to one of the Kubernetes API nodes. If something were to happen in flight, I think you would get an error, and you'd probably have to retry that API call. We don't have anything that's going to I guess handle that aside from kind of your typical HTTP error handling. But infrastructure-wise, yeah, there is a load balancer. So if there were a node or a zone or a control plane node that were to go down prior to a request being made, of course the load balancer will shift that traffic over to the surviving API nodes. But yeah, there's nothing, no magic, I guess I would say, under the covers that's kind of preventing an error from ever possibly happening. And I think that's one of the kind of the tenets of I think good infrastructure design, in my opinion, is to not try to promise those sorts of things, right? You know, errors are going to happen. So I think as another one of those best practices is from the infrastructure side, don't try to do the impossible, right? Errors are going to happen, and the caller of that API definitely should be able to handle those sorts of errors.
All right, great. Next question, is Kubernetes being employed here as a public cloud hosted service, and on which cloud provider?
Yeah, we started with Amazon. We are currently deploying the same thing in Oracle Cloud.
Okay. All right, great. Next question, can you please shed more light on the DSR use case? One, are you using it across public cloud and on-prem? And two, how are you configuring Kubernetes clusters to send traffic directly back to clients?
Let me take that one. So I did mention DSR in the on-prem infrastructure, and so 8x8 has some, you know, we have hundreds of microservices that run kind of behind the scenes of our essentially real-time application infrastructure. So, you know, voice and video is essentially a real-time service. For us, things like virtual machines, things like that, there's always some level of, I guess, that perceived or real performance difference that you may see for some of these real-time applications on things like VMs. And for us, there was another level of that, which was the networking side of it, where, you know, we have today 8x8 has a very kind of network optimized application. So, you know, we work really well with those kind of adverse network conditions, as well as, you know, of course, the whatever the network condition is, 8x8 kind of typically performs better in those sorts of situations. And that's due a lot to kind of what we've done on the networking side of our real-time components. So as we start looking at Kubernetes, one of the things that is sort of the core, how do I say this, the core pattern in Kubernetes is, you know, you deploy your pods and then you expose those pods to a service, and that service may be a node port service or a load balancer or something that's performing some network function on top of your application, whether that's a NAT or whether that's a load balancer with some state, you know, that it's keeping track of or something like that. For us, we really, in order to start getting more into the real-time aspects of it, we needed some way to kind of overcome those requirements, those patterns within Kubernetes. And so we're experimenting today with the notion of directly addressing pods kind of outside the notion of a service with Kubernetes. It's not something that's commonly done, but it is supported with Calico, which is part of the reason why we chose Calico. And what you can do in that scenario is you can actually define an address pool for public addresses, or it really doesn't matter as far as Calico is concerned. It could be a private address, a public address. Generally, you assign a private address to pods, but for some applications, they may not do well with a NAT or something in front that's sort of masking its public IP. So for those scenarios, we're looking to Calico to assign an IP directly to a pod. And because we're announcing those into our fabric, that allows us to send traffic directly to a pod. So that's really kind of what we're looking at there. And Citrix also does support DSR scenarios with Kubernetes, but today we're not using that, but it is something we're definitely looking at.
All right, great. We're about 6 minutes to the top of the hour. I think we have time for one, maybe two more questions. Here you go. Does your Kubernetes have multiple master/control plane components?
Yeah, I mean, the control plane is a set of redundant nodes, but we don't have two different complete, I don't think it works to have two different complete sets of control planes controlling the same worker nodes. but each layer is redundant, right? There's the persistence layer
Mhm.
for the control plane, which is typically etcd. There's the control plane used worker nodes that you have at least 3, and then there's your worker nodes that are actually doing your work.
All right, great. Let's see. Here's a quick one for you. What current version of Kubernetes is being provisioned here?
So we started 1.8 and we moved to 1.13, and those were both kind of hand rolled with Terraform, and now we're moving over to managed service Kubernetes services. So EKS, we're doing 1.16. OKE, I'm not sure exactly the highest level they support. I think it's 1.16, and then on-prem we're at 1.17.
All right, great. Here, I think the last question here, and I think you may have answered it already with your Calico answer a couple of questions ago, but is the container's IP address dynamically allocated through the load balancer?
Let me, real quickly kind of address that. So the pod IP is assigned automatically through Kubernetes' own internal, the CNI layer takes care of that in Kubernetes. So with Calico, Calico is assigning those pod IPs directly. So like I said, it could be a public, could be a private, whatever. When you deploy a service with something like a Citrix ingress controller, Citrix actually has the intelligence to go in and say, okay, here's your public side VIP or your service side VIP, and it's talking to all of these internal IPs for your internal pods, whether those are public or private or whatever. So hopefully that answers the question.
Excellent. All right, great. Well, we are about 4 minutes to the top of the hour, so unfortunately that is all the time that we have for question and answer period. I think we got to all of the questions, but if for some reason we did not get to your question, I apologize. And please know that the folks at Citrix and 8x8 will be getting a copy of all the questions that came in, so I'm sure somebody will be more than happy to follow up with you offline. Also want to remind the audience that today's event has been recorded, so you will be able to access it later on if you missed any or all of it, or if you just want to watch it again. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, before we shut things down, I did mention at the top of the hour that we would be doing a drawing for 6 $25 Amazon gift cards. So without further ado, let's go ahead and get to that. Our winners today are Anthony B. Congratulations, Anthony B. Our next winner is Eric S. Eric with a K, S. Congratulations, Eric. Next winner today is Jerry P. Congratulations, Jerry. And our fourth winner today is Zach with a K, M. Congratulations, Zach. Next winner is Matthew L. Congratulations, Matthew. And our final winner today is Alfred A. Congratulations, Alfred. We'll be following up with all of you offline by email to get your $25 Amazon gift card over to you. So please double check your inbox. It should be there. If it's not, check your spam. Yeah, so that'll be happening very soon. Gentlemen, Pankaj, Lance, Michael, thanks so much for a great presentation all the way around. Good stuff. Appreciate your time.
Absolutely.
Thank you
very
very
much.
much.
All right. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.